Okay, so we're starting to demonstrate and calculate how unbalanced forces changes the speed and or direction of an object. So we kind of discussed a little bit before we went out and did the tug of war about what it means to be balanced and unbalanced. We used some words. We talked about how balanced that it meant that it wasn't moving, how the equal on both sides, things like that. We talked about how unbalanced meant that they were moving and that they were unequal and everything. So we kind of discussed that before we went out and we did our tug of war last week. So we're going to kind of look at a couple of examples today. As we look at the first one with the flag, you'll notice that one arrow's going with a short distance and then the other one has a longer distance. So obviously the flag is going to move in the direction or accelerate in the direction with the greater force. So it's going to end up going this way. So as we're looking at it, I'm sitting there going, okay, well, it's going to go towards the right because I have more force there. When I look at the skateboarder right below, I'm looking at a little force going to the right, and we've got a bigger force going to the left. So that means that my object's going to actually end up moving towards the left. Then, our last two pictures we have on here, we have a horse, and when you look at them, the arrows seem to be the same. So if their same amount is being pulled on both directions, then we can conclude that the horse isn't going to have any motion, he isn't going to move. And then our last one is the basketball. It's being pulled up and pulled down, but the force pulling down on the ball is actually greater than the force pulling up. So we know that the ball will continue to go downward. All right, so what we're going to look at next is a couple of examples using newtons. We measure force in newtons. So as I'm looking at this, and I'm just going to zoom in a little bit, as I'm looking at this, I've got some notes down here that I'm going to take. If forces are moving in the same direction, we add them. Together. If forces are moving in the opposite direction, we subtract them. I don't know what I was doing. Subtract them. Okay, so we write that down there as our notes. So we have this written in at the bottom of our little sheet. If you don't have a printer, you can go ahead and draw these forces on there. But as I'm looking up here, I see that I have 50 newtons to the right and 50 newtons to the right. We said if they're going in the same direction, we're going to add them. So my net force, what it means by net force is the total force acting on the object. So the total force acting on the object is 50 newtons, and I like to put a little line through my ends, plus 50 newtons, and then above them I'm going to draw an arrow showing which way they move. So you can kind of see my arrows pointing to the right. 50 newtons and 50 newtons equals 100 newtons. And then I'll draw my arrow above it. So, are the forces balanced or unbalanced? Well, did the object move? If it moved, we know it's unbalanced. Describe how the forces will affect the motion. Well, this cube here, this kind of looks like a marshmallow to me, and it's going to move to the right. All right, so I'm going to come down here to example B. Well, now I've got 50 newtons going to the right and 50 newtons going to the left. So they're working against each other. I know that I subtract these. So over here, I'm going to put 50 newtons to the right minus 50 newtons to the left. Well, 50 minus 50 gives me 0 newtons. So is there any force acting on the object? Well, if I don't have any newtons acting on it, then I can say that it's called balanced. My object would not move. So then on the next one where it says how will affect the motion, there's going to be no motion. And then example C. Looking at example C here. I've got 30 newtons to the left, 50 newtons to the right. So they're working against each other. They're not going in the same direction. Again, it's subtraction. So I would take 30 newtons to the left and draw my arrow over it. The reason I draw the arrow is because I don't want to mess up on this. And then 50 newtons to the right. Well, when I subtract those two numbers, you're going to say, well, then it's negative 50. We're not going to go that route. We're just going to say it's not negative 50 there. It's just minus 50. I'm just going to say that it's 20 newtons, and I'm going to come to the right because my greater force is that way. We're not going to have negative forces working on these objects. So how will the forces, are they balanced, unbalanced? Well, if it has a number here, obviously it has to be unbalanced. And describe it, object will move to the right again. All right, so this is how we're going to kind of look at forces. The object's always going to move into the greater force. Okay, so make sure you have this down in your notebook, and then we're going to look at some labs tomorrow. Going into Newton's laws is our next topic. Okay.